In this video, we're going to prove the product rule. In other words, we're going to prove that if P of x equals f of x times g of x, then P prime of x is f prime x g of x plus f of x g prime of x. In other words, derivative of the first times the second plus the first times derivative of the second. We can write it in Leibniz notation this way. So how are we going to go about proving something like that? Well, first thing we'll do is we'll let P of x be f of x g of x. Now, if P of x is f of x g of x, then P of x plus h is f of x plus h g of x plus h. Now, we're going to set up our derivative by definition, P prime of x. In other words, the derivative of the function P of x is the limit as h goes to 0 of P of x plus h minus P of x all over h. And using this principle we just discussed earlier, that means that this will be our derivative right there. Now what we're going to do next is pretty clever. We're going to add 0 right in the middle. And that's a powerful weapon in mathematics a lot of times. So we're going to add 0 right in the middle, like we said a moment ago. But the 0 has to have a certain look in this case. And in this case, specifically, the 0 will be negative f of x g of x plus h plus f of x g of x plus h. If you add this red part that I've just indicated, if you add those together, they cancel each other out and it's a 0. So we're going to do it. And you might ask, well, why are we going to add that? You'll see as we continue on in later steps. We do it because it's going to help us prove. Now, if you look, what we can do is from this first part, we can factor g of x plus h out of there. And so in fact, when we do that, we get this expression. Factoring g of x plus h out of the circled part, we're left in the bracket, the second factor, as f of x plus h minus f of x. And looking at this part right here, we can factor f of x out of there, and we end up with this expression, where our second factor is g of x plus h minus g of x. Now, we're going to split this into two fractions. If you'll notice, what we've got is this part of the numerator plus this part of the numerator all over h. Well, we're going to switch that around to be the first part of the numerator over h plus the second part of the numerator over h. In a sense, it's just grade school fractions. And so that's what we get in this line here. We just sort of split apart that fraction. Now, instead of saying g of x times f of x plus h minus f of x all over h, I'm going to say g of x plus h times f of x plus h minus f of x all over h. I'm going to bring this part outside the fraction, and I'm allowed to do that. So to think of an easier example, 2 times 3 all over 7 is the same as 2 times 3 over 7. And that's all we're doing here. We're just bringing that first part out in front of the fraction as a whole. And that's what we get. Similarly, we bring this f of x out in front of the fraction as a whole, and this is what we get. Okay? Now, it's a property of limits, believe it or not, that I can take this limit as h goes to 0 expression that applies to the whole thing, and I can take that, and instead of applying it to the whole thing, I can apply it to each part. So I can say limit as h goes to 0 of g of x plus h times limit as h goes to 0 of this expression here, plus limit as h goes to 0 of f of x, and I've now dealt with this expression here, plus limit as h goes to 0 of all of that. And so you're allowed to sort of distribute out that limit as h goes to 0 expression the way we've just indicated. And you get the expression shown at the top of your screen. Now, the number one rule when we evaluate limits, we've talked about a few times before, is you just sub in since we're evaluating the limit as h goes to 0, I'm just going to sub in an h value of 0 to this expression that I'm determining the limit of. And if it gives me something that is defined, that'll be my answer. Well, if I just sub in an h value of 0 to g of x plus h, I get g of x plus 0. Well, g of x plus 0, that x plus 0, that's just x. So g of x plus 0 is just g of x. So this whole first part is simply g of x. All right, let's move to the second part. Now for the second part, we're going to look at limit as h goes to 0 of f of x plus h minus f of x all over h. I hopefully by now, you recognize that that is simply the definition of the derivative f prime x. Awesome. All right, well now let's look at this third part. This third part right there, the limit as h goes to 0 of f of x, there is no h at all in here. So f of x isn't dependent on h at all. So the limit as h goes to 0 of f of x will simply be f of x. And then finally, this last part, again, similar to when we looked at it here, that's simply g prime of x. And so if you look over these slides again, what we really have is g of x, f prime of x, plus f of x, g prime of x. And that's exactly what we were asked to prove. We'll just rearrange them a little bit, and we'll call it f prime of x, g of x, plus f of x, g prime of x, and this will be our final answer. And we've now proven that which we were asked to prove.